in general. And so what I try to have these graphics represent is in the top left corner, you see they're actually mutual funds. But if you've ever done any investing, a lot of mutual funds are based around what your target like retirement date is. So because you have a different use case, right? If I'm going to retire in 5 years versus in 30 years, you want to invest in different kinds of stocks, right? So software is much the same way. So when I deploy a web server, I might be doing development to the web server itself. I might be doing development like HTML. I might be doing a production deployment. Those are all the same piece of software, but they actually have different use cases. And using something like RPM or Deb or any other installation, you typically only get one style of install from that software. So that's a problem, right? You want to make it easy and discoverable to have different use cases. The other thing I show here is basically that software development itself has significantly changed in the last 20 years. We have things like Agile, and we have things like, basically there's usually 1 million lines of code or more underneath any software you're going to build before you even start, right? So that puts us way up here on the quote-unquote shoulders of giants. The other thing that's changed, particularly in the last 5, maybe 10 years, is the pendulum of who's in charge of what software is deployed and kind of makes it to users has shifted pretty heavily to developers. And that's what the little pendulum picture is for. The planes is supposed to represent that different software has different life cycles. So for example, you might have a piece of software on your system that just never updates, right? It just sits there, it does its thing, it's really stable, and you don't really need it to change too much. In fact, you'd rather it didn't change because so many things rely on it. But you have other software that's brand new and nascent, and it needs updates all the time. So how do you manage those different life cycles within something like a distribution, which is complicated because the idea of a distribution is that it all goes out together. And then lastly, this is, I'm not going to say it right, but it's Baobot, I think. But it's basically a kind of basalt ridge is what's in the bottom left corner, which basically, to me, represents really well the tight integration of the overall distribution, right? Everything is very, very tightly coupled, which is a good thing in the sense that when you talk about, kind of putting everything out and then everything can install, everything works together, but is a really bad thing when you start talking about lifecycle differences. Feel free to ask questions whenever. So the first attempt to try to start to solve this problem was this concept of rings. So it really just primarily addressed this idea that you have stuff that's relatively unstable, and as it gets more and more stable, it kind of goes into the rings, right? So basically, ring 0 is your kind of most stable, the things you want to change the least, kind of going out from there. And in Fedora, the way we started to deploy that concept was through the additions. So we have workstation and server and cloud, now atomic. I don't know what its name is currently. But they have different foci, right? So as a result, they can choose different software that's going to be in their kind of subset of the distribution. We also introduced Copper, which is a way to create basically the furthest out ring. So I have software that I just want to make available, maybe even just for me, for development, but I want to package it and I want to share it around, but it's not good enough to pull it into the actual main distribution. This is also where you might put stuff that is maybe the next but backwards incompatible version of something while you work on it, or while you make it backwards compatible. One thing that didn't actually really materialize was a concept called Playground, which was kind of meant to be a cross between Copper and trying to get into the ring, so kind of like that first outer ring after true development. And the proposal around that was called the Aleph proposal, but it kind of never really took. So moving on. So my problem with the rings metaphor, and if anybody wants to try and say that word, I'd be impressed. But that's what that is. And basically, this is a hypercube projected into a 2D plane. And yeah, tesseracts and all that stuff get really complicated. So, but if you notice, rings don't really work when you talk about an n-dimensional vectors, right? So the rings just work if you're talking about just straight up stability. But if you want to talk about things like lifecycle or use cases or whether things are actually included or not, what's installed and how it was installed and what it's built from, et cetera, it gets really complicated really fast. Also, when I was looking for pictures for hypercubes, I found this as like the 20th result. Like, really? Like, I love these guys. I thought they were hilarious. So, but they're the Fez development team, and they developed this piece of software called, well, the real game was Fez, but while they were building Fez, they built another game called Super Hypercube. I don't know what any of those games are, but I thought it was hilarious. So I apparently have a very simple mind. All right, so that led to the introduction of the concept of modules. So what are modules? Kind of in short, like I said, I'm kind of assuming that some people have some at least passing familiarity with this. But what they do is they describe an application. And we talk about RPMs as basically being the smallest unit of anything that we can do, so that we have so basically we can mix and match them together, right? But it also generally means that they also get very tightly coupled. It's not clear what the relationship is to a set of RPMs. So what we were trying to do with the kind of module concept is you describe an application. So a lot of people kind of think about this as meta packages sort of do this, right? Meta packages, they're not very discoverable, but they do kind of describe an application or something like that. They also are sometimes used for use cases, and this was something I discovered and have never been able to find again. But apparently there's an RPM for HTTPD that will put it into, that will automatically install it such that it's serving HTML from your home directory rather than from var www. So that's a really handy little thing, but it is impossible to discover, right? I Google, whatever, looking for it, and what I always find is the instructions to manually do it, not this super convenient RPM that just does it for you. So you have the different use cases. So you can kind of do that, again, with meta packages, but it's really hard, and it's not very discoverable. We also have the idea of parallel availability. So one of the things distributions don't do well is let you have, say, Python 2 and Python 3 available to the users at the same time. So the individual languages or the individual pieces of software may try to solve this themselves, and then just the distribution can just kind of take advantage of that. But that means that they all do it differently, right? So there's not a lot of consistency when you as a user are trying to discover whether you can parallel install something, whether you can have them parallel available, whether or not you can, what's available to you to use. The other thing that we tried to do with modules is a minimal UX impact. And what we mean by that is we wanted your kind of what I refer to as like muscle memory to just work, right? So even if we made all of these new things available, there's different kind of user experience, different use cases that are available, all this other stuff. We didn't want you to have to know about any of that unless you wanted to. So kind of, you would still have DNF install, HTTPD, and that would just work. But at the same time, if you wanted to get into it, you could start to say DNF install, and we have this interesting @ sign that's a debate point, but @ sign HTTPD : say 2.4, and then you would get a non-standard version of the HTTPD that was available. But you don't have to, right? It's just there if you want it. So that was a very conscious, careful choice we tried to make. We did some actual UX testing with this at Flock. I think it was Flock. Yeah, Flock, actually more than once. We've also kind of shopped it around internally at Red Hat. We've shopped it around using the Boltron release, which I'll talk about in a minute. Then the next thing we wanted to do with modules was, as much as humanly possible, make it so that the packager didn't have to do anything. Because obviously they're already doing enough work doing the packaging itself. Trying to introduce this kind of modular concept on top of that, that's a lot of work, or could be a lot of work. So we wanted to make sure we found a way to make that as small amount of work as possible. All right, so I have serious happy feet today. I keep walking around. So our first try. So I can't exactly remember when this came out, but it was a while ago now. Was the Boltron release, and thanks to Smooge, who came up with the term. It's a portmanteau of Voltron, which was a kids' TV show, which was about all these lions that came together into a stronger and more powerful robot, and basically the idea of a bolt-on. So with all these modules being things you could bolt onto your individual system. So we released this as kind of like a preview edition, basically mostly to generate that user experience feedback. I'm gonna have to move a little faster. There were a couple characteristics of this. So we used this bootstrap module to try to make things easier, but actually hid a lot of the problems that we've discovered later, which was really annoying. And so what it did was we kind of said, okay, we're just going to pretend that everything's already built, and then we're going to build these modules over here, and everything will, and then we'll figure out how to do the initial building part later. Yeah, it may have been a mistake. What we also did was we tried to say that there is this shared user space, we called it, which is the idea is that there's this squishy part between what's the operating system and what are the applications. Right? There's this squishy, messy part in here, which has been a recurring problem with the modularity team all the way through, is how do we define what that squishy part is? And do we decide that's part of the operating system? Do we decide that's part of the applications? How do we identify that part? How do we move that line up and down to give the applications the independence from the OS that we want to give them, but at the same time give them reliable access to the components they need? So that was another interesting component. And what we discovered was that the shared user space was very, very difficult to first design and build and then maintain. But we did do some cool things. We got some UX feedback. We got a working group put up. We did some guidelines and some processes around it. So we made some progress. And we did ship it. It just was, it was just hard, right? It was a lot harder than we wanted it to be. So then our second try, we went and tried to create the modular server itself. And as you saw from the title of the talk and my awesome picture here, we didn't quite ship it. It was actually pretty much done, but it was so difficult to maintain and so difficult to engage other people with because you kind of were forced to really buy in whole hog for everybody kind of all at once, which was never the intent. What we wanted to do was kind of ease into it. And so we decided to pull it back because we just didn't think it was something that would kind of reach the quality of something that was a Fedora edition. We made a bunch of UX improvements. We had 35 some odd modules. And we had kind of shifted the shared user space and bootstrap idea into this base runtime idea, which evolved actually into being called the host and platform idea. But they were all dealing with that squishy middle part. And assuming I move a little faster. So I've been talking about this all along. I just wanted to point out the picture. I searched for question mark, and I got this. All right. I can kind of see it, but I thought it was funny. So as it says on the side, I've talked about most of these. The one thing I want to mention, the EE module, and I didn't have enough space there to write the everything else module. So from the get-go, we had this idea that we wanted to make sure that this stuff we had modularized already was kind of over here, and we assumed that was going to be a pretty small box, right? But then there'd be the everything else module that would just be the grab bag of everything else that wouldn't be anything we would need to maintain or do work on, but it would make all the content that the rest of Fedora had made available to the modular server user or whatever. We never found a way to do that. That was like something that was maintainable, that worked well, and we tried to gloss over it. We tried to find random ways to do it. So shared user space was kind of an example of it. Platform was kind of an example of it, sort of. And so we tried a bunch of different ways to do it, and we just couldn't make it work right. And I think that ultimately is the key takeaway, was that not being able to work made everything else not viable. So that was a big part of the problem. Go ahead.
Could you just give a sense of what the relative size of that module would have been compared to what was in the modular server? I want to say it was something like 90% of Fedora.
Oh yeah, definitely. So the question was basically like, I said it was a small box for the modular stuff and a big box for the everything else. The everything else, what is Fedora's like 30,000 packages? 20,000? So imagine something like 17,000 packages in that everything else module, right? And then slowly over time, we'd try to move those things into the more modular thing. But because we couldn't get that 17,000 to work right, it just made kind of the whole thing not very viable.
That's a lot of else.
It's a lot of it.
That's a lot of else.
Yeah, a lot of else, yeah. All right, but there were things that went right. And I wanted to point these out because, what the modularity objective did allow us to do was start to think differently about what we were doing. Most of these were implemented by various people inside of Fedora. This is not the modularity team built any or all of this stuff. More like I think it was a catalyst for the changes. So the first thing I wanted to point out was kind of stream branching. This was originally intended for modularity because when we're defining those applications, we want to be able to say, oh, I want this RPM, and I want this version of the source and that version of the source, and I want to pull that into a module, right? But there's nothing actually blocking us from doing that for Fedora itself. And I would actually, like regular RPMs, and I would actually encourage this, because right now, if you look at the picture on the, it is the right way, right? All right, the picture on the left, this is what we do today for any random piece of software, is we have a bunch of different branches that have no relationship to each other, that only are about the release that they're attached to, right? They're not intrinsic to themselves. Do they know anything about the software, right? Whereas the picture on the right, sorry, the picture on the right is the software, and then you kind of just build it for the various versions of Fedora that you want to apply for. So you can do a bunch of different things here, right? You can say, I've got this 2.4.2 version available for F28 and F29, because there's nothing stopping us from building it for both, right? But sometimes we might have a problem where we have a CVE, for example, that only affects F28. Okay, so we do a little branch. That's fine, right? And then we go back to our merry way. And then we introduce a new version of something. Okay, so it's 2.6. We do the system-wide change, and we introduce that for whatever I have here, F30. But the F28 and 29 continue on while they're all three are overlapping, which is like a month or so. Oh, and I wanted to make one quick point. We initially called this arbitrary branching because from the kind of build side of the perspective, it means you can pick an arbitrary branch to build. Doesn't translate well to the humans who are providing the software. So we switched the name to be kind of from the developer side, which is, so the stream branch means the branches around the individual pieces of versions of the software, following upstream is kind of the idea. So if you see arbitrary branching anywhere, it means the same thing. It's just from the wrong perspective. Uh-oh. All right. Definitely running out of time. So distro innovation, that we can actually do software within the distro itself. We can make changes. We can do, we don't have to do the same kind of thing that we did for the last 20 years. So I thought that was important. This is my old picture of why distros are awesome. Gating and waivers, I think that really we were able to introduce kind of that we could do gating and waivers, and because we needed this again for modules, but now it's starting to roll out for RPMs. And Adam assures me that it'll all be better in a few minutes.
There's nothing wrong with it.
Right. But that's great, right? So we can actually now be able to say, in a kind of a nicer way, we can do it in a more automated way, we can say, keep the quality of Fedora up all the time. And then we've also started a focus on CI, right? So again, for modules, they don't work because of the combinatorial expansion unless you have significant amounts of CI. And so there's a talk about it at DevConf at some point. Let's see, 2:30 on Sunday. And I'm sure it will be entertaining because Dominic is really entertaining. So please go. And we now have a Fedora objective around CI itself, right? So that's great. We also, and I was talking to Ralph about this, one of the things that you needed for modules as well was a way to test them. But now because a module is a whole bunch of RPMs, we didn't really have a good concept of how do I get all of this set of RPMs kind of all together. So the on-demand compose service was introduced, and thanks to Jan Kaluza, oh, there he is, who I apparently wrote it over a weekend. And is starting to be deployed. I don't think it's available to everybody yet, but it is in production. So it'll be there soon. This is my crazy composer guy. So I don't know. I thought it was funny. All right, so what are we going to do next? OK, so what we did was we decided, you know what? We're going to cheat. And we're going to say the everything repo in Fedora is the everything else module. Right? So everything is available, but then we can layer on top of that actual modules. So we give up a few things here that Stephen Gallagher will definitely say we didn't actually have to begin with, but I still believe it. So we give up a few things about our awareness of what exactly went into the build. And one of the pictures I kind of dropped was bug-for-bug compatibility is important in this kind of modular concept. And so knowing exactly what's in your build root is very important. And you may or may not know this now, but the build root, you don't know what it is at any given time because it shifts, right? Every time anything updates, the build root moves forward. So as a result, kind of reproducing something that's bug-for-bug compatible is very difficult. So we have to give up some of those things because we're using the traditional distro underneath. But we think the trade-offs are good, like as in they're not bad trade-offs. The availability stuff is really interesting. We can pull more and more stuff into modules and start to get some of that back. And I wanted to kind of make one last thing. I don't think I'll actually do the demo, but I will. On the next slide, we have Stephen Gallagher's talk, who is going to go into a deep dive of like an individual module and how they work today and all that stuff. But the point of this slide is that the demo looks exactly like the demos of Fedora Server, Modular Server, or of Boltron, except for UX improvements. There is, from a user perspective, from a consumer perspective, it's the same. Oh yeah, and also it's already much easier from a packager perspective, and we think we might even get to the point where we can fully automate it. Okay, so his talk is, oh, look at that, it's right before Dominic's talk. So you can go to his talk and then go to Dominic's talk and do all the things Fedora. And that was it, because I have till 53, right? So I'll take some questions rather than show the demo, but I can put it on the screen to prove it works.
We believe you.
Exactly. Anybody have any questions? Oh, sorry.
Is this all going to land in beta and be working well?
You mean versus like production?
I mean, is this going to land by the time of F28 beta?
Yeah.
Okay.
This is important. This is an important enough objective to the council that I don't think I'd be outlined by saying that he was the beta.
Okay.
All right, so the question was, will all of this be available by beta? And my answer was yes, that's the expectation. A lot of it is working now. And Stephen Gallagher's response to that is also that the council may just delay the beta if we're late, so that makes it easier to be on time. All right, Ralph?
From my perspective, a lot of this stuff is already solved for previous releases. So, like, what are some of the things that still need to be done for beta that could make it late?
Yeah, so right now, okay, so the question was, what's on the to-do list between now and beta? And the biggest thing is, one thing we had never really solved was that the composes. So when we create all this stuff in Fedora land, we make what's called a compose, which is basically kind of makes call it the directory of where all the RPMs are. We never tried to solve putting a set or creating a compose that was RPMs mixed with modules before. So we think we have a solution to that. It needs probably a bunch more testing and then getting rolled out into production. So that's a big thing. There's also that automation I was saying is that we really need to improve the kind of ability to pull the modules in. I'm getting the hook right now. That's everything. All right, what do I do next?
Also, don't forget to rate the speaker and the talk in the defcon.chat.com.